We start NumPy module. Dividing NumPy or NumPy. NumPy or NumPy. NumPy or NumPy, okay. NumPy module. Right. See here, this is the all of observe. This is NumPy, okay, NumPy or NumPy. Next we see pandas and matplotlib. These are the third-party packages. Don't write, observe here. Third-party packages or modules. And these modules mainly used for data science purpose. They are part of the Python. They're part of the Python, but they mainly used for what? For the data science purpose. Which one? Maybe NumPy or pandas or matplotlib. Okay, right. So out of these three, first we learn the NumPy, then we go with pandas. Next we see the matplotlib. Okay, right. Now let us start now. NumPy, right? NumPy, right there. NumPy is a Python third-party module, which is used to create an arrays, to create an arrays. All of you. Let me know why do we use the NumPy mainly? Why do we use the NumPy? NumPy is used to create what? To create arrays. Right? Okay, right. So all of observe in Python we have the data structures. Right? What are those? String, list, tuple, set, dict. Out of those five, we know very well about the list, right? List. All of observe here. List is there. So in Python, while discussing the list and tuple, I will come to know that list is a little bit slow. Why it is slow? Because it allows always modifications. Every time it creates new object. See, all of the list, if you update any value, if you add the new value, remove the existing value, every time what happens now, it creates a new object. Right? So here, so as we know that list is a little bit slow. To overcome this problem, we create what here? Arrays. Okay, arrays same like list, but to overcome the problem in the list, we create the arrays. What's the problem? List is slow. Why it is slow? Because of it allows always modifications. Okay, so it takes buffer data. Right? Whenever we add the data, remove the data, modify data. The same all operations I want allow in the array also. The array also allow modifications. It also allows modifications, but it's very fast. How much faster? 50 times faster than the list. Which one? The array. How many times? Almost 50 times faster than the list. In a list, what we do? All we do here. Like which one? That add the elements, remove the elements, or item assignment, item list, all possible here. But still it's more faster than the Python list. That's why we learn which one here. We learn the which one? Creating the arrays. Right there. So NumPy arrays are more faster than which one? Python list objects. more fast than the Python list objects. Right. Now let us see how to create an array. We'll see now how to create an array. Here also it supports index numbers, forward, backward, indexing, slicing, all support here also. Same like list. In the list, what we do, we'll do all here, but still is more fast than the list. Okay. I open our file. Right. So I have to put it right. So first what we do, we have to install it. How to install it? Go to command prompt, and then what do we do here? Pip install what? Install numpy, right? Pip install numpy or numpy. So as we know that if it's available already, it displays which message requirement already satisfied. See, all these days we're working with Python ideally, right? Ideally. So today we'll start using the Jupyter notebook. Jupyter notebook. How first of all, how to install the Jupyter notebook? Same like pip install which one? Jupyter, right? Take the Jupyter, pip install Jupyter, so that it installs. This is the first step. All of it. We have to install like this. And how to open? How to open here? Here directly write the Jupyter one notebook. That's all. And click enter. It opens automatically. Two steps: install from the command prompt and open from here. How to install? Tell me now. How to install? Pip install Jupyter. That's all. Over. Now while opening the same Jupyter notebook, if I click enter, it opens now a page. It opens a page, and the page you practice this notebook. Right, all of observe here. So click here to go to what? To go to Jupyter. Yes, it opened the home page. This is the home page of Jupyter notebook, right? Right. So here, see, generally what we do here for every batch, I'll create separate file, right? Separate file generally. So here also we have to create a separate notebook for every. These are my previous batches. Okay. So what do we do here? Let's go to the new. Take the which one? Python 3. Click enter. It open the next page. Next page. Right. Here we practice. And what is the title here? And title is there. Means not saved. Okay, not saved, guys. Right? We'll save at the later. Now here we read the commands. Read the program here, right? Okay. First what here? Import what? Import numpy. Then how to execute this one, sir? How to execute in case of command prompt? Just to press the F5, right? You press the F5, it executes, output will come there. In case of this one, just shift enter. If you click the normal enter, it opens the for next line. Write the more number of lines program. Normal enter, right? But I want to execute it, right? Just a shift and click enter. Hold shift, click enter. It executes output display here only. We'll see now. So numpy, right? I take the alias name as np. Alias name as np, guys. Alias name np, right? Now np dot which function we use? Arrays or array. We'll check once. Okay, I think array, right? Array. So here I can use the only one value, right? The array is in different dimensions: 0-dimensional, 1-dimensional, 2-dimensional, 3-dimensional. Like 0D, 1D, 2D, 3D. 0D means giving the only one value. Only one value. It may be integer value, or float value, or bool, or complex, or a string value. And in array, we have all same type of elements. Generally, in BTech, we know a definition of array. What is the array definition? Anyone? Collection of collection of variables. Any other? Elements, correct. A little bit more is there. One more extra word is there. Collection of similar type of values. Collection of similar type of values means maybe all integer values, or all float values, all string values, all bool values, like that. But list has both homogeneous, heterogeneous elements combination. But here no combination. Take all integer values, or all float, or bool, like that. Okay. So I am taking the one value 10 assigned to one variable. Suppose array 1 equal to, right? Array 1 equal to. I am going to print which one? Array 1. That's all. I want to execute it. How to execute this one now? Just shift enter. Now it gives C. A star is there. Means executing, processing, and over. What is the one? One means one time execution over. One time execution is done. Right? Now open the second box automatically. Now you can modify if you want. You can always use this one. You can modify the code. No problem. Or else leave that one and execute here. In our ideally, what we do? We comment the previous program. We comment it. Write the new program. But here comment not required. We will comment it, but not required, because I can write one more program here. I execute this one. Only it will execute. It will not execute next time. If you want the same one modify, you can go here. You can modify. I can take suppose 10, 20, 30, for example, guys. If I execute it, then what happens here? Suppose I'll take the one more value, guys. I just take the something 1000. Right? Now again, what we do? Shift enter. Shift enter. Now, how many times over now? 2 times over. And what's output here? 100. Right? Now, we'll see here. We'll see now. Print is over. Print means what's the meaning? Display the value. Right? Next one, type of array 1. Type of array 1. Which type here? ND array. If you create an array by using array function, it's called ND arrays. ND arrays. In NumPy, we create the arrays. Those are called ND arrays. N-dimensional possible. Like a 0-dimensional possible, 1-dimensional possible, 2-dimensional possible. That's why that's called ND arrays. In NumPy, what do? We create which one? Arrays. Which arrays? ND arrays. ND means n number of dimensions. N means I don't think 10 dimensions, just either 0 or 1 or 2 or 3 max. Enough, right? Okay. So here, now, this is which one here? Example of 0-dimensional array. 0-dimensional, right? Now, how to create a 1-dimension, sir? How to create a 1-dimension? Okay, 1 dimension. Here, to increase the font size, just what we do? Plus. Click the control plus for the zoom purpose. For zoom out, which one? Minus. That's all. Okay. Minus. Again, I take the import NP as NP. Again, same NP dot which one? Array of. Now I want a 1-dimensional array. Already what is over now? 0-dimensional. Now what I want now? 1 dimension. So 1 dimension means a collection of 0 dimensions. Collection of 0 dimensions. In 0, how many elements are there? Only 1. Collection of 1 elements is called which one? 2 dimension. Sorry, 1-dimensional array. Right? Like suppose if you have the only one value, it is the 0 dimension. Now one more zero, one more zero, one more zero, one more zero. Now this is called which one? One dimensional array. Like a list. A list is which dimensional now? List is a one dimensional object, you can say that. Okay. Now it's over. Assign to the one variable. Suppose I take the array one, and print here, print of what? Print of array one. What we do? You can see now it's like a list. But what is difference? In the list you have the commas. Here no commas. When you see both, how to identify which is list, which is array means in the array no commas, but list commas are there. All of right. Okay. This is what here, which dimensional? 2D, right? Sorry, 1D, right? Now take here type of which one? Area one. The type of area one. Which one here again? Which one? N dimensional. Right? Suppose I want to display number of dimensions is a 0 dimension or 1 dimension. Just go here. Now area 1 dot n dim. I want to display that number of dimension. Is it 1 dimension or 0 dimension, like that? Okay. Let us try now. I'll take the print. We'll take the print. All of observe. Which dimension? This one? 0 dimension. Which one? 0 dimension. And coming here now, I take the print of that array one. Which dimension? N dim. What's the attribute name? N dim. N dim. Which dimension here? 1 dimensional array. So 0 dimensional and 1 dimensional array. Next one. Let's go with the third one. What's third one? 2D array. Right, 2D array here. Again, all of import numpy as np. Right. Let me know. What do we do? Np dot array of. So 2 dimensional means collection of 1 dimensions. Collection of 1 dimensions means what's 1 dimension? List, right? We take the list format. Right? Okay. We take the now n number of list formats. Right? So first one I take here. Suppose 1, 2, 3 over. Again, I'm taking now one more. 1, 2, some other numbers I take here. 4, 5, 6. Again, one more. Suppose 7, 8, 9, like this. Right? So 2 dimensional means a collection of 1 dimensions. 1 dimension means collection of what? 0 dimensions. All right? Now it's over. Assign to what here? Some variable array one. Then we take the print of array one. Yes, sir. Again, this all we must make as an argument, right? So what do we do here? We take the one square bracket beginning and at the end, so that to make all as one argument. Now you can see. So n dimensional, sorry, 2 dimension, 2 dimensional. It's like a matrix. We know the matrix, right? Matrix we know. So this is which format now? Matrix. If you use 1 dimension, it is the like a list. If you use 2 dimensions, like which one? Matrix. Okay, matrix, guys. Next one. Let's try here n dimension. So print of array 1 dot n dim. N dim means number of dimensions. Which one here? 2 dimensional array. 2 dimensional array. Right? Fine. Now the last one we see. What's the last one? 3D, right? 3D. 3D means what here? Collection of 2Ds. Collection of 2Ds, right? Again, import numpy as np, then np dot array of. This is the, see, I'm taking the as is, guys. I'm taking the that as is. This is the 1 2D, right? This is the one. This is the 1 2D, comma. So here, what happened now? One main list object is there. One main list is there. In that list, again, what is there now? Collection of list objects are there. All right. See, first of all, one main square bracket is there, beginning, ending. In that one again, one more list object, one more list. Here also, what do I do now? Again, what do I take the one main list? In that one, again, one sublist, comma, one more, like this. I'll take. All of it. Then It has some elements here, something 3, 4, 5, and here some 6, 8, 2, and let's take now 1, 9, 8 like this. Okay, right. Now assign to which one here? Array 1. Then you take here print of what? Ending is missed here. Here is square bracket, right? Missed. And overall we keep the one more bracket, overall bracket, right? We keep all. So beginning one square bracket. At the end also what we do? We take the one more square bracket to make overall. See, if you observe clearly, the last bracket coming in the green color. Here also you can see the green color, all of you, right? That means now a main object is in this one. Again, sub objects are there, right? Now let us try here. Print of what? Array 1. Let's see now. We can see now, right? All of you. This is the suppose 1 2D, and this is the at one more 2D, and overall this is the last bracket is there, and here which one first bracket is there, right? And here print of array 1 dot which dimension ndim, which one 3D is there, right? 3D like this, right? So 0 dimension, 1 dimension, 2 dimension, and